Okay, good morning all guys. So now we're going to see about the Banker's algorithm. Solve the following using Banker's algorithm. Consider the pi system process, that is P0 to P4, like P1, P2, P3, P3 and P4. These are the 5 process and a resource types which are given under the allocation and a max A, B, C. So these are the resource types. Find the need matrix and find out whether the resultant system state is safe or not from the given snapshot. So this is the problems were given in the exam. This is one type of example for solving the Banker's algorithm. It comes for 8 to 10 marks in the exam. So now we need to find out the need matrix. So for finding the need matrix, the formula is need equals to max minus allocation. So the formula is need equals to max minus allocation. So now we need to find out the need matrix for each process. For finding the need matrix, the formula is need equals to need minus allocation. So now we're going to find out the need for each process one by one. So what is the need for each process for P1? So max is 7, 5, 3. And we need to get subtract with the allocation. So 7 minus 0, 7, 5 minus 1, 4, and 3 minus 0, 3, and for P1, 3 minus 2, 1, and for 2 minus 0, 2, 2 minus 0, 2, and next 9 minus 3, 6, 0 minus 0, and 2 minus 2 is 0, and next 2 minus 2, 0, 2 minus 1, 1, 2 minus 1, 1, and 4 minus 0, 4, 3 minus 0, 3, 3 minus 1, sorry, 3 minus 2, 1. So this is, we identified the need matrix for the each process. So for finding the need matrix, first question is done, find the need matrix. Next we need, so finding the need matrix is done. So next we need to find out the whether the system is in safe state or not. Okay, now you find out the safe state or safety algorithm. Now like that formula is need, so need smaller than or equals to work, or the work can be also called as an available. So for you need to identify the safe sequence, we go to the process one by one. So for P0, what is the need? So need is 4, 7, 4, and 3, but work is available. So this available is also called as an work, and work is 3, 3, 2. So the condition is not satisfied, so which is says false, and it jumps to a next process for P1. So what is the need of the P1 process? 1, 2, 2, and available is 3, 3, 2. So condition is satisfied, so that is true. So after finding this, again we need to find out, so the condition is satisfied, like P1 is granted, so which is in safe state. So next we need to identify the work. So work is equals to work plus allocation. So work is 332, is 332 plus allocation of P1. So allocation of P1 is 2, 0, 0. So 3 plus 2 is 5, 3 plus 0 is 3, 2 plus 0 is 2. So now this becomes new work. That becomes the new work. So next we'll go for the next process for P2, and again we'll check the condition. So what is the need of P2 P2 is 600 and available of work or available is 532. So again it is not satisfied, we call it as a false. And again we'll check for P3. So what is the need of P3? 0 1 1. So work available is 532. So condition is satisfied. So and again we need to find out new work. So work is equals to work plus allocation. Work plus allocation. So what is the work? 532 and allocation of P3. So what is the allocation of P3? So this is the allocation. The allocation of P3 is 211. Allocation of 211, that is equals to 5 plus 3, 7, 4 and 3. So now this becomes new work. So now we check for the P4. Again we need to check the condition. So what is the need of P4? 4 3 1 and available is 7 4 3. So this is also condition is satisfying. So condition is satisfying. Again we need to find out new work. So work is equals to work plus allocation. So work is equals to 743 plus allocation of P4. So what is the allocation of P4? 002. 002. So which is nothing but 745. So this becomes the new work where this condition is satisfied. So it is granted. So next, the safe sequence. Again, so after completion of all process, again to check for the any processor left out. So again to go back to the back, wherein which checks the condition where the condition of P0 is not satisfied. So to check for the P0. So P0, what is the need of the P0? 743. So the 743 is need and available work is 745. So condition is satisfied, granted. So again we need to find out the new work. Like work is equals to work plus allocation. So work is 745 plus allocation of P1. So what is allocation of P1? 0 1 0. That is 755. It's done. Next, so remaining process, P1 is completed, P2 is not. So we'll check for the P2 process. So for P2 process, again we need to check we need to satisfy the condition. What is the need of the P2? 600 and what is the available work? 755. So the available work is 755. So condition is satisfied. So we need to identify the new work plus allocation. So work is 755 plus allocation of P2. So what is the allocation of P2? 7 for P2 302. That is 7 plus 3 10, 5 and 5 plus 2 is 7. So this becomes the new work. That becomes the new work. So here we need to write the safe sequence. Safe sequence. So it's very difficult to write here with one hand. So please excuse. So here first we check with the safe sequence. So P1 is not satisfied. Sorry, P0 is not satisfied. P1 is satisfied. First is P1. Next P2 is also not satisfied. Next is P3. So next P3 is done, P4 is also satisfied, P4, next P0, next P2. So the safe sequence are P1, P3, P4, P0, P2. The safe sequence are P1, P3, P4, next P0, P0 and P2. So this is a safe sequence for the given problem. Thanks for watching.